name is Srinivas Govada. I am working as assistant professor in IARE college. Now we have a case where the data has been, the server has been crashed, but luckily we have a database copy. Okay. Now we'll see how to restore the database. Now, crash recovery. DBMS is a highly complex system with hundreds of transactions being executed every second. Okay. The durability and robustness of a DBMS depends on its complex architecture and its underlying hardware and system software. If it fails or crashes amid transactions, it is expected the system should follow some sort of algorithms or techniques to recover the lost data. Okay. So suppose due to its hardware or system software failure, it crashes in between of transactions. It is expected that system should follow some sort of algorithms or techniques to recover the lost data. Okay, we'll see few categories to see whether the problem occurred. To see where the problem occurred, we generalize a failure into various categories as follows: transaction failure, logical failure. Okay, first, a transaction failure. A transaction have to abort when it fails to execute or when it reaches a point where it cannot go further. This is called transaction failure, where only a few transactions or processes are hurt. See, it has to abort when it cannot go further. It's called as transaction failure when only a few transactions or processes are hurt. The reasons for a transaction failure could be logical errors, where a transaction cannot complete because it has some code errors or any internal error conditions. So at this point, due to the logical errors, there would be a transaction failure. What is system errors? The transaction failure could also be due to system errors, where the database system itself terminates an active transaction because the DBMS is not able to execute it, or it has to stop because some system conditions. For example, in case of deadlock or resource unavailability, the system aborts an active transactions. So transaction failure is of two types. One is logical and other is the system errors. The logical is when there is some error in the code. Oh, that is the logical. However, but the system errors, it could be due to the resource unavailability or to the deadlocks. System has to abort an active transaction. Also, there is one more thing: system crash. There are problems which are external to the system, and that may cause the system to stop abruptly and cause the system to crash. For example, interruptions in the power supply may cause the failure of underlying hardware or software failure. See, when there is a power interruption, may cause the hardware and software to fail. Example may include operating system errors. Suppose your server failed to boot, then failed to boot after restarting. Then it is also system crash or disk failure. In early days of technological evolution, it was a common problem where the hard disk drives or storage frequently used to fail frequently. The disk failures includes the formation of bad sectors, unreachability to the disk head crash, or any other failure which destroys all or a part of disk storage. So, system crashes or disk failure. Okay, when your backup to disk due to bad sectors or unreachability of the disk or disk head crash, your data is there is a failure. The transaction have to abort. In brief, the storage structure can be divided into two categories. Storage structure can be divided into two categories. One is the volatile, second is the non-volatile. Okay. First, see the volatile storage. As the name suggests, a volatile storage cannot survive system crashes. Volatile cannot survive system crashes. Volatile storage devices are placed very close to the CPU. Normally, they are embedded on the chipset itself. For example, the main memory, the cache memory are examples of volatile storage. They are fast, but they can store only a small amount of information. This is about the volatile storage. They are embedded on the chipset. They can be forms of a main memory or cache memory. They are fast, but they can hold only small information. Whereas non-volatile storage, these memories are made of to survive system crashes. These are made to survive system crashes. They are huge in data storage capacities, but slower in accessibility. Examples may include hard disk, magnetic tapes, flash memory, non-volatile battery backed up RAM. These are all the non-volatile where they can store huge data, but accessibility would be slow. Examples would be a hard disk, a magnetic tape, flash memory, or non-volatile RAM, which is backed up by battery. Now, we'll see the recovery and atomicity. When a system crashes, it may have several transactions being executed and various files open for them to modify the data items. So in system crashes, there are many transactions being in operation and various files are open for modifying the data item. But as far as the right thing, transactions are made of various operations which are atomic in nature. But according to the acid property of DBMS, the atomicity of a transaction as a whole must be maintained. That is, either all the operations are executed or everything is rolled back. So the atomicity says that it should be as an atom unit. If it is executed successfully, everything should be correct. It has got failed, everything should be rolled back. So when a DBMS recovers from a crash, so we'll see when a DBMS recovers from a crash, it should maintain the following. It should check the states of the transaction which are being executed. Okay. The first thing is it should check the states of the transactions which were being executed. Second thing is a transaction may be in middle of some operation. The transaction may be in middle of some operation. The DBMS must ensure the atomicity of the transaction in this case. If it is in the middle of the operation, then it must either roll back or complete it fully. So here the DBMS must ensure the atomicity of the transactions. Third thing is it should check whether the transactions can be completed now or it needs to be rolled back. So after the crash, the DBMS should check whether transaction can be completed or it needs to be rolled back. No transaction would be allowed to the DBMS in an inconsistent state. No transaction would be allowed to leave the DBMS in an inconsistent state. there are two types of techniques. There are two types of techniques which can help a DBMS in recovering as well as maintaining the atomicity of a transactions. There are two techniques which can help DBMS in recovering as well as maintaining the atomicity. Okay. First is maintaining the logs of each transactions and writing them onto some stable storage before they actually modify the database. See, the two techniques are writing the logs of each transactions, writing the logs of each transactions to some stable storage before actually modifying it. You want to modify X to Y. So before you modify to Y, you write to log it. I'm going to change from X to Y. After writing that, then you can modify actual data. Maintaining shadow paging, whereas the changes are done on the volatile memory, later the actual data is updated. First you do on the volatile memory like a chipset or on the read-only memory on the device. Shadow paging is that first you do changes on the volatile memory and later on the actual data is updated. There are two techniques here. One is first writing to a log, first to maintain the log, first writing the log, then modify the actual data. Or in second case is that first you make changes on the volatile memory, then later the database itself. Okay. Now let us see the log based recovery. Okay. Log is nothing but a sequence of records which maintains the records of actions performed by transaction. Log is a sequence of records. Log is a sequence of records which maintains the records of actions performed by the transaction. See, any operation you perform in the database, it is recorded in the logs. See, in the database we have two files. One is MDF, other is LDF. The LDF is nothing but the log file. So anything you do on the database is recorded in the log file. Okay. It is important that the logs are written prior to the actual modification stored on the stable storage media, which is fail safe. See, it says that the logs are written prior to the actual modification stored on the stable storage media, which is fail safe. Suppose you want to modify the value of X to Y. So before modifying actual database, first it is written to a log file and it's stored into stable storage, and then the actual value of X is changed to Y. Okay. A log based recovery works as follows. First, the log file is kept on the stable storage device media. The log file is first kept on a stable storage media. So when a transaction enters the system and start execution, it writes a log about it. Transaction TN start. See, when the transaction enters the system, so it writes a log saying that transaction number and it is start. So when the transaction modifies an item X, it writes log as follows. TN is transaction number. You're trying to modify the value of X from V1 to V2. Okay, this is right in the log file. The transaction number is TN or N means any number. X is the data item which you want to modify. V1 is the original value. V2 is the modified value. It reads TN has changed the value of X. Change the value of X from V1 to V2. When the transaction finishes, it logs TN commit. Okay. Here, TN start is the first is starting the operation. Starts execution as T start, ends with T commit. In the between, it writes the T transaction trying to modify the data item X from V1 to V2. This is log based recovery. The database can be modified using two approaches. One is deferred database modification. All the logs are written onto the stable storage and the database is uploaded when the transaction commits. See, all the logs are written onto the stable storage and database is updated when the transaction commits. Okay, this is the committing. How does the commit happens? After the logs are written on the stable storage, later the database is updated. Okay, when the transaction commits. Immediate database modification. Each log follows an actual database modification. That is, the database is modified immediately after every operation. So this is the first thing is after the database is committed, your database is updated. But here, the second case is at every step it is modified. Each log follows a actual database modification. That is, the data is modified immediately after every operation. Now, recovery with concurrent transactions. When more than one transaction are being executed in parallel, the logs are interleaved at the time of recovery. It could become hard for the recovery system to backtrack all the logs and start recovering. To ease this situation, most modern DBMS use the concept of checkpoints. See, when they are in a huge system, there will be many transactions going in parallel. So, at the time of recovery, it will be difficult to backtrack all the logs and start recovering. So, we will have a concept of checkpoint. Okay, now let us see checkpoint. See, checkpoint is that, say, suppose your state, your start is your position is A, you want to be here. Okay, you have series of steps 1, 2, 3, 4. You can say checkpoint 3. It means till here you have you have saved, you have committed locally. Checkpoint B. Something happens at this point. Safely, you can go back to 3 and start working from there instead of going back to A1. Okay, we'll see it. Checkpoint. Keeping and maintaining logs in a real time and in real environment may fill out all the memory spaces available in systems. Keeping and maintaining logs in real time and in a real environment may fill out the memory space available in system, because see, transaction will be doing many transactions per day, and to maintain logs of each transaction and storing it, you could eat up all your available memory. As time passes, the log file may grow too big to be handled at all. See, over a couple of days, the log file will be so huge, it will be difficult to handle it. So, the checkpoint is a mechanism. Checkpoint is a mechanism where all the previous logs are removed from the system. So, checkpoint is a mechanism where all the previous logs are removed from the system and stored permanently. See, at suppose 1, 2, 3, 4, 5. You have taken it back up here, and this is checkpoint. So, when this is applied, all things prior to this 3 can be safely be removed. As we have a checkpoint at 4, it is stayed till there. So, checkpoint is nothing but a mechanism where all the previous logs are removed from the system and stored permanently in a storage disk. Checkpoint declares a point before which a DBMS was in consistent state and all the transactions were committed. For example, here, this is the transaction T1, T2 starts here, T3, T4. We have a checkpoint here. Suppose there is a failure here. That is, failure happened when the transaction T4 is being done. The transaction at T4 is being done. So, when the failure is, there is T3, T2 are also failed because you have not taken backup. You have only backup at the checkpoint here. Till here you have backup. So you have to start your process again from here to here, not from here. You don't need to start from here. You have to just start from here, the checkpoint. Because prior to that are all saved to database. The recovery system reads the log backwards from the end of last checkpoint. This is the end of the log checkpoint. It reads backwards. The recovery system reads the logs backward from the end of the last checkpoint. End of last checkpoint. End of last checkpoint. It maintains two lists. One is undo list and one is redo list. If the recovery system sees a log with T1 start and T1 commit, T start and T commit, or just Tn commit, it puts the transaction into the redo list. See, when it sees a log with T start ending with T commit or just T commit, then it puts the transaction into the redo list because it has to do once again. If the transaction sees a log with T start but no commit or about log found, then it has to undo the transactions. Suppose you have you're transferring from X to Y amount of 500. If there is a start and commit and there is failure, again you have to do it. You have to again redo. Remove 500 minus from here. Suppose if there is no commit, there is only start. That means there is no ending here. So we have to undo the operation. So we will have to earlier we have deducted 500 from X. Again we have to undo this operation. You have to again add back this 500 to him. Okay. All the transactions in the undo list are then underdone and the logs are removed. All the transactions in the undo list are then undone. One by one are undone and the logs are removed. All the transactions in the redo list and the transaction logs are removed and then redone before saving the logs. That earlier I was saying that undo means you have to undo all changes. Suppose if there is anything in the redo list, you have to do one by one before saving the logs. Okay, this is the database recovery.
Like, share and subscribe. Hit the bell icon for more updates.